So, welcome back to another stream. Today, we're going to be talking about silent aim detection. I know. How would you go about actually, A, making silent aim, and B, how would you go about detecting it? So, for this stream, we're really going to be trying to dive into A, like how are silent aims made? And B, we are going to kind of experiment and kind of just generally figure out how we can detect it, how we can prevent it, and maybe some methods to minimize any errors, so any false detections. So without further ado, let us jump into VS Code. We're going to be using a Rojo based workflow. So we're just going to be putting all of our scripts and stuff on the file system. So if I need to, I can, upload it to GitHub. So let's get started. The first thing we're going to kind of be going over, how are silent aims made? So if you don't actually, here's a briefing of what a silent aim is. A silent aim is pretty much a player. Hold on, paint.net's on. So I have a player here, and this player is looking this way. So the player's looking forward, but there is another player, or a hostile, color him green, or yeah. I meant red. Anyway. So we have our hostile. What silent aim is when this player shoots. So shoots. It will correct, in quotes, the aim of the player. So what this means is when our remote is fired, instead of saying, hey, our person is looking this way, let's use this, our person's looking this way, it will actually say, hey, our person's looking this way. We're actually looking right here. So, how can we get around this? Well, the theory that I've kind of, that I've come up with is, so if the player is going this way, and the hostile's over here, and they're saying, like, hey, we're over here, is it possible that I can say, okay, well, these two positions are different, or these two directions are different, and that is kind of just an immediate red flag. Now, if it's something like the hostile is here, and they say, hey, I'm looking right here, it is significantly more believable due to ping. Ping can drastically affect certain situations like this. Find soft lock, so real. So we would take the two directions, kind of like check them. Are these at the very least similar? And if it's something like they're aiming all the way over here, then that's definitely a red flag. But we do also want to try to see, like, hey, are they also falsifying these two directions? And that's what we're going to try to figure out today. Is it possible to detect something like this? Now that we have our preface done, I am going to open a script that is from a now outdated exploit called AsTopUp. And this was one of their scripts that was used for silent aim. So you can kind of see that they have a name call. So name call, kind of explained it here, is the method used on the object. So example, workspace raycast. The actual name of the method would be raycast. And then the caller would be, you may have guessed it, the script that called method or used workspace raycast or :raycast. So if I had my script dot, or if let's say I have my client script here. So if I go ahead and call workspace raycast, this hook meta method will pick that up and say, okay, so this would check, are they, I think check caller is, are they native? Like, are they Roblox? Like, is it a standard call? I believe that's what it is. Or maybe it's exploit. I don't know. I'm not too certain about check caller. But when the client calls this method, it will be picked up because __ name call is what is being used. So get name call method will return raycast, and the caller will be right here. It's two pieces of information that are kind of necessary. If we wanted to bypass an anti-cheat and the client consistently makes requests to this one remote, then we can kind of say like, hey, that is maybe something we want to get around. So if the client is calling check for check for hacks or whatever, fire server, we can check, we would be able to check the object. So that would be self here. You could say, okay, well, it's going for check for hacks. So this would be check for hacks, and we could say check for hacks.name if we wanted to get the actual name of it. And the name call method would be fire server. So we could hook fire server and kind of forge our own arguments. We could realistically manipulate whatever we want, which in our case, not optimal. So we have the method here, find part on ray with ignore list. So this is, I think, an old version. I think find part, I think it's a deprecated version of raycast. Might be wrong, but I'm pretty sure that's what it was. And they check like, hey, is silent aim enabled? They want to check if the caller is there. So if the script exists and the script's name is client. So that kind of just narrows it down. Like, hey, it's probably this script. And they're gonna go ahead and spoof the raycasts. So this means like, hey, we're going to forge this amount. We're just gonna call it good from there. Then we get the root part. They kind of have an interesting way of doing that, but I'm not gonna judge. And then they get the character, so the enemy, the hostile, that's closest to our player. Character, and character. Huh? Why would it? Oh, it's probably the player. So they just named it wrong, I guess. But anyway, as you can see, when they return the arguments. It is head and head dot position. So this is pretty much the direction. This is the direction. It is the target and direction. So how are we going to go about combating this? We're going to need to set up a basic example of silent aim. Let's go ahead and do that. I'm going to create a remotes folder in replicated storage. I'm going to add a remote event, and then we're just gonna call this shoot. I think that fits perfectly for our use case. And we can go ahead and add that here. Hold on. Okay. So we can go ahead and get, if I could spell, we get replicated storage. And then we can go ahead and get our shoot remote event. Remotes dot shoot. So when we go ahead and get this, we're gonna try to do something a little bit interesting. So in this case, Arsenal, this is where it's taken from. It's their Arsenal script. So Arsenal has the target, so the target object, and in this case, they're gonna want to go for the head. So we can actually take advantage of that. How, you may ask? Or how you might be asking. Well, we can take the player, we can take the current direction, and there was one other moving component. Let's just build out the basic shooting for now. So we're gonna go ahead and just we'll create a part, actually, just to kind of visualize the raycast and where it might be going. Part name, visual, or shot visual, part apparent workspace. Yep. Transparency 0.5. Part color is color 3.new 0. Part. There were some other ones that were, yeah, can collide. False. Part dot can query. False. Part cast shadow. It's false. And part anchor. It's true. All right. So now we kind of have our basic shot visual. We do, however, need to get the character so we can, if they actually hit something, we can modify the size a little bit, the size of the shot visual, because it does look just a little weird if the shot would just go straight through them and then keep going. So we're gonna go ahead and say, okay, if not character, we'll return. we'll get our character, or say origin. Character dot head dot position. And then we will get the result. Workspace, raycast, origin, direction. Then I think we would just want to go something like 100, for example. And we will say raycast params new, add to filter, add the character, and then I think wrong apparently. Filter. Ah, okay. So I do need to put it on its own thing. Raycast. Yo, I would love to be able to speak English. So we're gonna add our character to the list of instances to, hold on, params filter type equals enum raycast filter type exclude. So we're gonna take our size, and it'll just be direction times 100. Pretty much just like that. I think might. Oh, wait a minute. I think I might be having a moment. End position. So the end position are 100. But if the result is there, then the end position is just going to be result position. So this by itself means nothing. So what we're going to want to do is just go ahead and say C-frame. Hold on. So the direction, yeah, okay. That's what I thought. So we're gonna do C-frame look at, just simply because this is the easiest way to get the thing. Origin. I'm struggling. I don't know why. So wait, cframe.new origin times cframe.new direction times 100. Okay, that maybe might work. And then just grab this dot position. Okay. So now we have our starting and end position, and we should be able to get the size based off of the distance between the two. So we should be able to say origin, and that will be our size, if I'm correct. Part size, part dot position equals origin. So that should be fine. Okay, so we're gonna head back into our init.client.lua, and I'm actually gonna disable the aimbot cheat that we made last stream. We are gonna keep the ESP, just makes it easier for debugging purposes. So we're gonna go to input begin connect function input object is process. Okay, so we're gonna check, hey, is the user input type not equal to enum.user input type dot mouse button 1? So we're just gonna want to check, hey, are they clicking? And for now, we're not gonna put any like sanity checks on the server to see like, hey, are they trying to shoot too quickly? For now, we're just going to do, actually, I'm gonna copy and paste this. Hold on. Should be able to just copy and paste this without any worry. Yeah. Okay. So when I shoot, I will say character. I'm gonna get the player.character. Yep, okay. If the character doesn't exist, then we will just return. There's no point in trying to send a request over when there's just no reason to. So we can go ahead and get the direction of the... We'd actually want the camera direction. Hold on. Because that is kind of where we're going to be going. So camera dot look C-frame dot look vector. There we go. And we can just send that direction over. And that's it. That's... Oh, I forgot to connect. Whoopsies. Yep. Go ahead. So now anytime we click, we should be able to create a little line. Very thin, but it works for now. And realistically, we want to get the delta, and we can just correct the sizing problem by just doing something like you can do 0.5, 0.5, and then delta dot z. Yeah. Oh, I think I did it backwards. Oopsies. Y and Z. Delta dot Z times 2. I mean, as long as I can just make it bigger, I don't think it's all that much of a concern. I just need to make sure to not make the actual size any longer. Oh, right. I think I might have messed that up just a teeny bit. Something's not computing, and I don't know what it is. Oh, wait. I wonder if that is the issue. I can't see it. So it's slightly a headache. times 100. I don't know. Oh, I probably should have kept it the other way if I was going to do that. Because that would make the Z larger and my problems more. Ah. Yes, the comically large line. I think it was the X. What would it? Am I tripping? Maybe. I might need to bust out the math skills. By that, I mean putting a part in a workspace and messing with it. Oh, wait a minute. I can say the C frame is equal to it's a little cheaty, but oh, that might actually be why, because it's not doing all that funny stuff. We'll just do this. Put it there. Part dot. Oh, wait a minute. I already have the origin. Ow, my back. Sorry, guys, I'm an old man. Partially. So here we're going to try to do some madness. Yeah. We'll try that. I mean, might as well. It's the fact that I can't see it that is... I don't know how to deal with that. Why are they so small? Oh my god. Okay, so yeah, do need the delta. And vector 3 dot new 11 delta dot z. I think it's going backwards. So I would really just... Huh. Is it the reported direction that's my... Oh, wait. We shall... Oh. Might also be because I did this. It looks a little weird, but I mean, maybe. No, that was correct. Okay, that's what I thought. Yeah, no, I'm just gonna subtract that. Worst case scenario, gotta do some fancy schmancy stuff. Huh. Very concerned. It sometimes goes where it's supposed to, and sometimes it doesn't. Very interesting. Could probably get the orientation by doing something like look at this vector dot 0 direction and then taking cframe.new origin times cframe.from orientation, and then orientation to orientation. I know, very intuitive naming scheme. Or names, name, yeah, that one. I'm very concerned. Okay, I'm just gonna look it up. Raycast, visualizer Roblox. Wow. Now I do want to make this clear. I've made Raycast visualizations multiple times before. I'm just I'm having problems right now. Result dot position. See, that's the. Oh, that makes sense. Yeah. Yeah. No. No. Yeah, that makes sense. All right. So I'm just gonna. So it is that, but we get the magnitude. So this becomes the distance. And then this guy did 0.1, 1. Obviously, we don't have to follow that, but I'm gonna do it just because, why not? And since it's here, I'm gonna add this to list of references. So yeah, this is what I was looking at. Not gonna lie, I completely forgot to do this and this, which are kind of the only parts that matter. But yeah, no, it's fine. It's fine. Origin and position. So this is to, as far as I know, this is to just get the orientation based off of the origin, or relative to the origin. There we go. And we're gonna add debris to that because I don't want to see it forever. Add item, part. We'll do 3, I guess. Okay, well, now that that's done, we now have bullet visuals in quotes, and we can now kind of see, like, hey, you know, we have our ESP, but when we shoot at it, you know, nothing really happens. It's like we are playing as a normal player for now. So let's actually replicate the silent aim. So how would we actually go about it? Well, what we can do is take this code, first of all, and second of all, put it here. Get the, we wouldn't actually need the mouse location, I don't think. Yeah. Don't need that either. Body part. And here we will say, like, hey, let's aim for the head. I'm just gonna switch this to any. I can't be asked. And then we will take the camera C-frame. So we're gonna get the direction a little bit of a different way. So with this version of our silent aim, the silent aim we're gonna make is it will just shoot at all of the NPCs at once. Obviously we could not do that, but it does make it just a tad easier to do. Say origin. Then we'll say direction equals head dot position minus origin dot position. Then I think we would want to normalize that. So now when we fire, it's going straight to the person's head. We're not even aiming over there, and it's going straight to the person's head. It shouldn't be going over that way. Like, why would it be going that way? Who's over there? And it just so happens that this guy, this guy right here is the in our case the NPC who's getting cheated on right now. That sounds bad. Okay. But you know, our NPC's behind the wall. So how would we actually go about figuring out, is this possible to detect? Is it feasible at all? Like, it doesn't necessarily make sense, Batman. Well, to you I say, if there is a problem, it can be fixed. So let's go ahead and try to fix it, shall we? So we are going to get, we're gonna do a little bit of magic. I know you didn't want to do magic today, but we're gonna do a little bit of it. So we're gonna take the look vector from the head itself. So I'm going to just kind of try to gauge what actual numbers would look like in our case. So let's actually comment this out. We'll grab this, have this here, and we'll say origin dot look vector. So this would be, if it was legit, we would be taking the camera, going the way that the camera's looking. And we should have similar numbers. Unable to cast coordinate frame to vector 3. Did I accidentally throw in a vector? Or a C-frame? Where? Line 36. Origin. Oh. Whoopsies. We'll do. Let's do head position. Character dot head. Oh, wait. Origin dot position. And then I will put that stuff here. TM. Origin. Okay. Cool. So now let's try to see what we're working with here. So as you can see, these numbers are actually quite similar. So if I were to, I don't like how Windows forces me to save a screenshot when I'm not trying to. So head look vector, and this is the reported look vector, aka our direction. So these numbers, even though they're different, are quite similar. The head look vector changes not so much, but it does stay usually within a similar range. Now the same cannot be said for the Y here, and I'm assuming that's because the camera kind of messes with that a little bit. But how can we kind of figure out, like, hey, why is this guy looking weirdly? So from what I'm seeing here, we generally have, and this will obviously change due to ping, so if you're going to try to, here's my disclaimer, if you're going to try to make your own version of this, you need 110% to compensate for ping. And that is the end of my rant. So anyway, so when we have something like this, you know, we'll have our normal stuff here. You can see this is kind of similar. Hold on. I don't have. Okay, so you can see that these are similar. These are not similar. So we'll we'll cross those out in like orange or something. So we can't really rely on these to be consistent. But if we come over here, it looks like these are semi-consistent as well. So this tells me we might be able to create a basic form of detection for silent aim by using the head's look vector and the provided direction that the client says that it's looking at. So if there is a huge margin of, if there's just a huge difference between them, that would probably be a good indicator that something's wrong. So how are we going to go about that? Well, realistically, what we could do is just get the difference. We get the delta. I'll actually put this in a do statement. We'll say check for silent aim. We'll get the delta. We'll say we'll say the look vector of the head comes first, and then the provided direction, because they are bound to be different. And let's actually just warn that. Delta. Let's move these up. So the distance between those are pretty big initially. But when everything kind of gets together, and if they're staying like maybe still in this case, which is unrealistic for a majority of games, the delta for that is actually seemingly under 30, like under 0.3. So if we were to realistically try to get the absolute value of that, and I'm assuming this does have to do with just differences in the time that the server actually receives it, the request, that is. So moving forward, what information did we get out of this? Okay, well, we can kind of see that the difference is decently consistent if you're standing still. But what about if we're moving? So that is where we get numbers like 0.55, 676, 192, etc., etc. Now, what if we were to enable silent aim? In quotes. So this is our silent aim. It normally has over 0.5. I'm not even looking. I'm not even looking in the same direction as the other as the NPC. And it is incredibly large. You can see as I get closer, the number kind of chills out. So I am kind of in the same area. When it comes to this, I'm not even looking, but the server will say, you know, hey, we see that you are looking at the character, which is false. I'm currently lying to the server right now. So let's check if the delta for X, we were gonna want to get the absolute value because they will change based off of the like which way you're facing. That will change. And let's just say, for example, less than 0.6 or greater than 0.6. Or delta dot Z is greater than, well, we'll say 1. We'll say if it's greater than 1. I think those numbers are also inflated, but we'll figure it out. Math.abs delta.x. And obviously you would want to change these numbers to fit your own use case. So in the case of this, we'll want to warn like, this player is cheating. I mean, more than likely. And we shall see, like, hey, it's registering that I'm cheating. It is registering that I am in fact a cheater. Now I am noticing that when I'm fully turned around, it is having problems. So I'm wondering if I could get a total. So delta.x plus delta.y plus delta.z, and maybe print that out as well. Kind of get a better sense of what these numbers might look like. So when I'm fully turned around, it is consistently, for the most part, more than 1. So let's say we'll get the absolute value as well. And we'll just see what this number looks like. 1. I did notice that the original check, I forgot to check the absolute value of that. So right about here, it stops noticing if the player is cheating. If we come over here, pretty much the equivalent of that, it stops noticing that the player is cheating. But if we come over here, I'm just looking just elsewhere, can kind of get a good sense of, hey, maybe this person isn't legit. So over here, similar deal. If I'm looking all the way over here, I'm more than likely cheating. If I'm looking about here, then it will register like, hey, this person's probably not legit. I am going to quickly revert this because I do want to see if maybe I have better results doing it this way. Yeah, so if I'm looking to the complete side, it's not gonna be too happy with me. But hey, if I'm looking over this way, and I'm just going ahead and shooting at them like that, then it's gonna quickly if they're out of view, it's gonna quickly register, okay, this person's a little bit suspicious. You can modify this whatever way. If you wanted to, you could say like, hey, maybe I want the Z to be 0.8 instead of 1. And this will make it a bit more strict. But, like I said before, this can cause problems. I want to see if I'm actually looking at the player, if it will flag me for cheating. So let's just try to figure that out. And we can actually use the aimbot. And we'll just disable this for now. So we can actually aim at the player directly, or maybe around it. So we're looking straight at the player, and doesn't look like we've had any false detections. We're looking straight at the person's head, and we're even inside. When we are on top of it, it does seem to get a little mad. But that is more than likely due to this. The head being something that does not also move like the camera. But if we're like this, we're just doing this, we're fine for the most part. Let's actually disable the delta as well. I thought that's what I disabled, but apparently not. And it seems like, for the most part, we're not really having any problems. Let's try doing... this. So, we'll emulate, in quotes, an automatic weapon. So we'll do 0.1 for the time between shots. User input service is mouse button press enum dot mouse. Oh wait, user input type dot mouse button 1. Oh wait, until that is not the case. So if I'm going like this, it won't detect it. And this is to at least try to safeguard it. Now, if we do get too close, it's going to get mad. So, obviously, in your own way, you would want to try to figure out how to fix this problem. But, as a basic form of cheat detection, we can check like, hey, they are pretty far. They're not even looking in the same direction. So, with that ends today's stream. Thank you all for coming out and just tuning in, having some fun. Take care. Bye bye.